Hello, welcome to Talk Math. Today we're going to be doing the integral from 0 to pi over 2 of the natural log of 2 sine squared x all over the natural log of cotangent x dx. Now, when I first look at this, I initially want to think, is there any way I can simplify this expression using log properties or trig properties? But other than changing this into maybe separating this out, I don't really see anything, and that wouldn't work because it doesn't help us simplify the denominator. And so my next thought is I see the bounds go from 0 to pi over 2, and we have trig functions. So I think of using a reflection identity, and that is saying u equal to pi over 2 minus x. And the reason why this might be useful is because you can use cofunction identities to then try to simplify these expressions. So let's try that path. So u equals pi over 2 minus x. And then that would obviously make du equal to negative dx. And then if we want x is equal to pi over 2 minus u. So now rewriting this integral, we have this equals the integral from pi over 2, changing the bounds to 0, of, we have natural log of 2 times sine squared of pi over 2 minus u over, now over here we have natural log of cotangent of pi over 2 minus u du. Now we can employ the trig cofunction identities. Sorry, I forgot this negative sign. So now I'm going to use these negative sign to flip the bounds of integration to make this from 0 to pi over 2. And now on the inside we're going to have the natural log of 2. Now using the cofunction, this is going to become cosine squared of, and instead of u, I'm going to change the dummy variable to x, and you'll see why in a second. So cosine squared of x over natural log of cotangent, except because the cofunction is going to become tangent of x dx. So now what do we want to do? Well, I noticed that these are very similar forms. The only difference is this is a cotangent and this is a tangent on the denominator, and I want to be adding these together. And so in order to do this, I'm going to first change this tangent to a cotangent, and then we can do that by using a log property that we can bring a negative to the outside right here, and then change this to a cotangent. And the reason why this works is because if you bring the negative to the inside as the exponent, then the cotangent to the negative first power is just going to become tangent. So now we can add these two together. And what we'll get is this integral, which is I, which is what we're going to solve for. So let's just say I plus I, we're adding 2 of that same integral. So we're going to get 2I equals this plus this. And so when we add these together, we're going to get on the numerator, well, first of all, the integral from 0 to pi over 2. Now the numerator is going to be natural log of 2 sine squared of x. And now over here, when we add this, we're going to take this negative and bring it up here. So we're going to have a minus natural log of 2 cosine squared. And now in the denominator, we'll have all over natural log of cotangent of x dx. Now we can use log properties to bring these two expressions together. So we'll get the integral from 0 to pi over 2. Okay, so bring these together, we'll have a 2 sine squared over 2 cosine squared. The 2's will cancel, leaving us with a tangent squared. So the natural log of tangent squared of x over natural log of cotangent x dx. Now this is we're almost done, because again, using the same thing up here, we can bring a negative to the front and change this into a tangent. And now we can bring, using another log property, we can change this fraction of logs into one log property. So this will become the integral from 0 to pi over 2 of negative log base tangent of x of tangent squared x dx. And so now it's just using a log property that you can to change the base formula. So now we see that log base tangent of x of tangent squared x is just going to become 2. So we have this is equal to the integral from 0 to pi over 2 of negative 2 dx, which is just equal to negative pi. However, we didn't want to solve for this. That was 2 times what we want to solve for I. So we need to divide both sides by 2, and we get that I is equal to negative pi over 2, and we are done with the problem. Thank you for watching. I really hope you enjoyed the video. Please like and subscribe if you want to see more like it, and feel free to leave any comments or suggestions down below.